All right, here we go. This is Advent of Code 2021. Um, a few things to note. One is that I moved to Texas, so that means I'm on Central Time Zone, which means that when the problems start, um, that's 11 p.m. my time, which is past my bedtime. I can't stay up that late, so I won't be solving them right when they come out. I'll be solving them hopefully the next day, in the afternoon sometime. Um, the second thing is that, over the past year, I've been doing a lot more managing than I have been coding. So I'm pretty rusty from a coding perspective, although I've done a lot of code reviews. But so we'll see how that goes. I haven't written a lot of code over the last year. So this will be fun from that perspective. And then the third thing is that I have GitHub Copilot, which writes code for me. And so if you follow my Twitter, you've seen I've done some experiments trying to get it to say naughty things or get it in trouble basically. But I actually haven't really used it for writing code. So I think that'll be an interesting experiment as well. And I'm actually kind of curious to see what it does. It works surprisingly well, but not perfectly. So anyway, all that said, I haven't looked at the problem yet. So let's do it. Sonar sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready. It's covered in Christmas lights and even has an experimental antenna that should be able to track the keys. It's a little meter, blah, blah, blah. This is, okay. That's just the intro. Collect stars by solving puzzles. Good luck. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. Small screen, the sonar sweep report appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you have the following report. Wanted blah, 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 blah. Scouting outward from the submarine. Depths of this. The first order of business is to figure out how quickly the depth increases. Just so you know what you're dealing with. You never know if the keys will get carried in deeper water. To do this, count the number of times a depth measurement increases from the previous measurement. Increased. Okay. How many measurements are larger than the previous measurement? Okay, so that sounds relatively straightforward. So now let us input. Let me call it raw equals, and then input equals, so this is GitHub Copilot right here. That is what I was going to write, so that's pretty good. I may have to turn off Copilot because it may actually be too good at this. I don't know what version of Python. That's what I was going to type too. This is kind of eerie. Okay, I know in later versions of Python you don't have to do that, but def count increases depths, which is a list of ints, and it's going to return an int. Count equals 0 for I in range len depths minus 1. Okay, if depths I is less than depths I plus 1, count plus equals 1. Okay, and then it also needs to return count, which is good. And then I want to assert that, okay, that's good too. And assert that count increases input equals 10. That doesn't seem right. 1, 2, 3, 4, 5, 6, 7 is what I get, and it's 7 measurements. Okay, so let us run this. Python day01.py. Okay, so that works. So now let's say if name equals main. Why don't I get my puzzle input? And I will stick it in day1.text. Okay. With open data day1.text as f, raw equals f.read, or I'll just do raw equals f.read, input equals, okay, that seems good, and print. Okay, I wonder if enough people have done this already that it's basically cheating by looking at other people's advent of code work. That would be interesting. So let's do this, and it says 1446. So we will try that. That's the right answer. Continue to part 2. Considering every single measurement isn't as useful as expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example, start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A, their sum is this. The second window is marked B, its sum is this. Sum measurement, second window is larger. Your goal is now the number of times the sum of measurements in the sliding window increases from the previous sum. So compare A with B, then compare B with C. Stop when there aren't enough measurements. In the above example, the sum of each 3-measurement window is how many sums are larger than the previous sum. Okay, so I see a trick here, which is when I go from let's say ABC to BCD, then all I'm doing is I'm subtracting A and adding D, right? So as long as D is bigger than A, it's going to increase. And as long as, and if D is smaller than A, it's going to decrease. So what I'm looking for is basically the same thing I did before, but with this gap, right? So all I need to do is go back and just, let's say gap int equals 1. And so now what I can do is minus gap plus gap, do that. And now assert that count increases input gap equals 3 equals 4. Let's see. 5. Okay, so I didn't get that one right. That was a little bit weird. 5. Okay. And so now let's print count increases input gap equals 3. It knew to do that, which was pretty smart as well. Okay, no, I don't want this next thing it's offering. So let us try running that again. I didn't save, so let us try this one more time. 1486. Okay, let's try that. Part of me worries that it's not going to be right, but we'll try it anyway. Hey, that's the right answer. 1 gold star closer to finding the slate keys. Okay, so that was that. And one, you saw that GitHub Copilot did a lot of the work for me. In fact, it wrote the first version of this count increases function, which is basically it's basically cheating, right? So don't tell anyone that I cheated. I mean, obviously I'm not on the leaderboard, so it doesn't really matter. But the second thing you saw is it's not perfect. It gets a couple things, small things wrong. So you can't like really trust it. Like it wrote my asserts. Actually, this assert it wrote right, but this assert it wrote wrong. I wouldn't expect it to get it right. And then the other thing was just my cutesy trick of noticing that you know, to do this sliding window, if you want it to increase, like the delta of the sliding window is just, you know, one minus the other. So it's basically the same. You can use the same function and just make the gap a parameter. So that was, yeah, that was pretty straightforward. Like I said, I'm not going to stay up late tonight to wait for tomorrow, or to wait for day 2. So I will just be back here tomorrow afternoon, probably around this time. I think this time, which is, I'll probably do them at 4 p.m. my time, 5 p.m. my time, Central Time. So do your own time zone conversion. Things are good in Texas. Thanks for asking. And yeah, so that was it's good. And yeah, don't tell anyone I cheated. Okay, see you next time.